like the first 5 seconds. Number 3, again, what I expect, what you're going to hand in, you're going to just hand in whatever I write up here. Number 3 says, decide whether normal sampling distribution can be used. If it can be used, test the claim about the population proportion P at the given level of significance alpha using the given sample statistics. On number 3, and I sort of lied to you on this part too, because I said, if they put a problem in the book, they're not going to make it so you cannot do it. Well, number 3, you can't do. You can't use it. So write can't, and the reason you can't use it is if we take, what was in this time for number 3? If you don't have a book, get one out so you can help me. 40 times our P, which is 0.12. And have out your calculator so you can help me. What is 40 times 0.12? Quicker we go, the better for you. So Grant, not having that book open, pull that desk where they're closer to you. Open up that book. 4.8. That ends up being 4.8. Well, 4.8 is less than what?
Less than 5.
It's less than 5. So that's why it won't work. That's less than 5, so it won't work. So we can't use, it's not normally distributed, we can't say that it's normally distributed. Number 4.
Wait a minute. Oh, okay.
That's, if you did all that work on that one, that's my fault, because I told you that I probably wouldn't give you any that wouldn't work, right? So even if you did all the work, it didn't hurt anything, because now you understand the process a little
I
bit.
was thinking that was 9 or something, and was really confused why you didn't get all 5 parts.
Number 4, we decide on number 4, if we take 0.48 times 90, well, 0.48 is about half. Half of 90 is going to be like 45. So both of them should be plenty big enough on this one, right? They're both bigger than 5. And all we're going to do on this one, we're going to first, we can use, then we write our HO and our HA. Test next week over this stuff, and this is what you're going to have to do. You're going to have to HO, HA, this whole chapter. That's the way it was. This time the claim was P is greater than or equal to 0.48. Well, that's going to be our HO. That's our claim. Make sure you write that. Then our HA is going to be P is less than 0.48. Next thing I do whenever I see this is I decide what tail it is. I lost my paper here, what I do with it. We're saying P is greater than or equal to, might be something that we write down somewhere here real quick, just so I don't forget it. If it's greater than or equal to, does anybody have that on that chart that we wrote down a couple days ago? What is it? Left-tailed, right-tailed, or two-tailed? Left-tailed. If it's less than or equal to, then it's right-tailed. And if it's equal to, it's two-tailed, right? So we'll write that over there so that we don't forget it and we don't have to keep looking it up every time. So this time it's left-tailed. Then I come out here, I draw my stuff. We know it's left-tailed, that means it's right here. We're looking for that number, and that's going to be our rejection region. The way we find this number on your chart, you figure out your alpha. Your alpha this time was, what they tell us our alpha was on number 4, 0.08. So what we do is we look up on the chart, under the areas, what's the closest to 0.08? Alright? If we're on this end, it's probably going to be on which side? The positive side or the negative side? Negative side. So we look on the negative side. Spill that all over my floor.
Fell on me, man. It almost fell.
Negative side. I don't care if it almost fell. I don't want it on my floor. Negative side. We look over here at 0.08. Looks like 0.0793 is about the closest. And remember, you're looking it up using the chart backwards. So it's negative 1.41. So that right there is negative 1.41. That's our critical value. Does everybody understand that? Yes. Does that make sense how to find that critical value? Because that's the part I sort of had messed up last time. Jacob, you act like maybe you're confused. That confuse you? Don't lie to me. Ain't nothing wrong with not understanding something every now and then. Whole point of being here, right? Is to learn. So you look up whatever your alpha is, 0.08. If it's left-tailed, we try to find 0.08 in this chart. Well, 0.08 is not in this chart anywhere, but we figure out what's the closest. And then we come back over here and up to here and make up the z-score. Once we do that, then we're going to find our z. To find our z, your formula to find your z, and I'm going to write this over here so I don't have to keep writing it every time and don't have to keep looking it up or asking you for it. It's p hat minus p over, what was the rest of it? Square root p times q, is that right? Over n. So we're going to use that formula every time. This time our p hat for number 4 was 0.40 minus our p was 0.48. Have your calculators out so you can help me with this and we can rush through this. I know this first one's taking a while, but hopefully the rest of them won't take this long. P is 0.48. If P is 0.48, what's Q? What do you do to find Q?
Minus
1 minus that, so what's 1 minus 0.48? 0.52. Divided by n. This time they told us n was 90. On the top, I can do the top part here. That's negative 0.08. Somebody do the bottom part for me. Square root 0.48 times 0.52 divided by 90. So we'll say 0.53. Now what do we do with those two? Divide it. So we got negative. I know it's going to be a negative. What's 0.08 divided by 0.053? 50 what? 9. So 1 negative 1.51. After we have our z-score, this is what we're checking. So we're going to check this and we're going to see where does it fall in this little graph that we made up here. Well, I look right here and it looks like, ignore that extra part that went down there, looks like it's going to fall right about there. If it falls in there, what's that tell us to do with our null up here? If it falls in the red region, what's that tell you to do? Reject it. Reject the null. And they want you to actually write out all that stuff. For this one, it seems stupid to write out all the stuff. Reject the null is fine for me on this because they didn't really tell you any kind of situation that you're doing. On the other problems where it actually tells you, this company's making this claim or this is doing this claim, then we write out stuff, but that's good enough for this one. Jesse, that all makes sense? So everybody got that one? We're gonna go a lot quicker now. Oops, that's not what I wanted to do. Number 6. Or number 5, sorry. Thank you, Green. Number 5, we can use it, our HO. On number 5, our HO is P equals 0.15. Our HA then is going to be P is not equal to 0.15. That was our claim this time. I look right here, I see the equal to sign. I know that that's going to be two-tailed. Come over here, I start to draw my stuff. I know my graph's going to look something like this. Rejection region there, rejection region there. Next thing we're going to do is find that. The way we find it is by using our alpha. Our alpha this time on number 5, they tell us was 0.05. If it's two-tailed, what we do is we take that 0.05, we divide it by 2, and you get 0.025, and we look up that area in the chart. All right, we're going to have two numbers this time. One of them is going to be the positive, one of them is going to be the negative. So I'm going to look up on the negative side because we want the one over here, then we can just make it positive for the other end. So 0.025. Let's see, right there is 0.025. Negative 1.96. So our critical value, negative 1.96. Make sure you know how to look these up on. That's probably the hardest part of this whole problem, is finding those critical values. So you just look up right here on this chart, 0.025, and it actually has that number on it, 0.025. If I could find it again. It's right there. And we go negative 1.9, and then it's got a 6 on the top row. So that means this number right here, this critical value is 1.96, negative 1.96. This one's positive 1.96. Then we're going to find our z-score. For our z-score, we take, somebody help me out so I don't have to keep looking back. What was p hat on number 5? You guys are going to make me keep looking back, aren't you?
Yes, 0.12.
0.12. What's our P is 0.15. Square root 0.15. What's Q if P is 0.15? 0.85 divided by what was in. They told us in the book.
500.
I can do the top part. That's negative 0.03. Somebody do all that bottom part for me. Somebody divide it. You know it's going to be a negative. Looks like it's going to be negative 2. Is that right? Comes out even, negative 2.
Yeah.
Where's negative 2 fall at? We do something wrong here? I don't see it.
It's in the.
What did it go? 1.5 what? What was after that? Somewhere right here. 1585, 500. Do that square root right? So I got something different. Second square root 0.15 times 0.85 divided by 500.
Oh, I put 80.80.
So it actually comes out to be 0.016 there, right? So it's not. Somebody divide that because you round that up. -2 was in the region, this one's out of the region, so it's close, but it's gonna be somewhere right in there. So what's that tell us?
Failed.
Fail to reject the null. So we fail to reject the null this time. Number 6. HO, HA. This time their claim was P is greater than 0.70, so that's going to be our HA. That's the claim. That means our null hypothesis has to be P is less than or equal to 0.70. If it's less than or equal to, that tells us it's a right tail. Right tail. So when I come out here to draw it, right tail, I have to think. Here I make fun of you guys sometimes about left and right, and I have to remember which one's my left and right. I lose you, Jesse.
So
They told us
that
P.
would be a left tail, wouldn't
We always look at this.
it? Oh, I thought you look at the claim.
No, you always look at the null hypothesis. Got to find this critical value, our alpha this time. What was our alpha for number 6? 0.04. If it's left tail, then what we got to do, we're looking on this chart, we're not actually going to find this area. We actually want to find this white area, because the Z chart tells you the area to the left all the time. The chi chart, the other one that you grabbed up here, tells you the area to the right. I don't know why they made them backwards that way. It seems like it'd been easier to keep them all uniform, but so we don't want this 0.04. This is the 0.04, the red part. What we got to do here is take 1 minus 0.04. What is 1 minus 0.04?
0.96.
So we want to find the z-score that goes along with the area of 0.96. So we look up 0.96. Is that going to be on the negative or positive side? Positive, because we're over there, right? So 0.96, and it's not going to be probably exactly 0.96. We just want whatever's the closest. Looks like 0.9. So there's something that closer than that, isn't there? 0.96. 0.96. Oh, you meant 08? Is that what you meant? Looks like actually 0.9599. Is that pretty close to 0.96? That's probably the closest. So it looks like 1.75. So this right here is 1.75. That's our critical value, 1.75. Then we find our Z. Help me out again. What's our P hat? And our P is 0.70. Square root 0.70. What's Q if P is 0.70? 0.3, 0.30, doesn't matter really. Oops, no. Yeah, there's a fraction more there. Divided by, what's in this time? 225. I can do the top, that's negative 0.6. Now, before I go any farther, if that's a negative 0.6, no matter what we get on the bottom, when we divide by a negative by a positive number down here on the bottom,
It's gonna fail.
it's going to fall in this area, isn't it? So regardless of what we get, it's going to fall in this white area. It's not going to fall over there because we're not coming up with a positive number. We're coming up with a negative number, and it has to be over here. We'll finish it anyway. What do you get when you do all this? Oh, that's the final answer? Negative 0.714? And that's gonna fall somewhere like right here, right? No, I don't have one, but here, come up here and grab this.
Mine like works, but like after about 30 seconds, it just turns off without even touching your.
Probably the batteries in. Bring yours up and I'll just put the batteries in it. So we got that. That falls there. What's that tell us to do? Fail to reject. Number 7. This might come up and write the HO and HA for me while I'm getting Grant some new batteries.
You guys know it?
That'll be
What's HO? Huh?
What's HO?
He is, less than or equal to
It's kind
0.45.
of just like that, not very equal, so.
Yeah.
I think it was the last one.
I don't know.
Yeah.
I don't know.
So what?
I can look.
That's good.
Yeah, me too. I'll tell you what, I did crap on that one.
145.
Oh, I didn't do very good.
I actually made a call. And then you do the opposite.
Yeah.
There's 100 in there.
That was on this
That's about 3/4 of the cost.
What do you do after you have the HO and the HA?
one. That's a claim.
Make the claim. There's one thing wrong with this. What's wrong with this? No equal to on the HA. So
And that's an or. I actually did that.
HO is less than or equal to 0.45. HA, please make sure on your test, because I'm old, I can see your decimals, because I've marked several wrong in geometry here lately, because people make little decimals like that and I can't see them. All right, so make sure you make your decimal big enough. Once we know that, we look right here, right-tailed. That's our right, so it's going to be over there. Our alpha, what's our alpha? Look in your book and help me out. What's the alpha? Number 7.
0.05.
0.05. If it's right-tailed, we got to do 1 minus that 0.05.
0.95.
0.95, we look up that area on the chart. Whatever's closest to 0.95, is that going to be on the positive or the negative side? Positive side probably, right? 0.95, ooh, it's right in between those two. It's right in between 1.64 and 1.65. So this is what I'm going to do. It's right in between 1.64 and 1.65. So I'm just going to make it 1.645. That means this number right here is 1.645. Then we find our Z. What's our P hat this time?
0.52.
I know our P is 0.45 because what Jesse wrote down here. 0.45 is our P times 0.55 is our Q. What's our N this time?
100.
On top, I know that that's 0.07. Somebody do all that bottom for me. If you guys are doing it, because Riley's told me the answer is just straight out. If you guys are putting all that into your calculator all at once, that's fine. As long as you're making sure, because when you start putting in parentheses and stuff, you guys, I know you're smarter than me, so it doesn't confuse you, but when I start putting in all those parentheses, I get confused. 0.05? What's 0.07 divided by 0.05? It's 1 point something. 1.4? Where does that fall?
Not in the left.
Not in the rejection region, right? So what's that tell us? number 8, another one that I messed up on. Can't use, and the reason you can't use it on number 8, if you take 0.95, somebody help me out, what's 0.95 times 50? So that's bigger than 5, so that's all right, right? But what's 0.05? That's the Q times 50. 2, it's less than 5, so we can't use it on this one. So number 8, just your answer just has to be you can't use. Number 9. Somebody read the problem in number 9 to us so I can write down stuff as you're reading it. Come on, we only got like 10 minutes.
The medical researcher says that less than 25% of the U.S. adults are smokers.
Stop right there. So P is less than 0.25, right? Every time you come to a number,
Sure.
stop sign right.
All right.
In a random sample of 200 U.S. adults,
N is 200.
18.5 said they are smokers.
So that's P hat. 0.185.
Alpha equals 0.05. Is there enough evidence to reject the researcher's claim?
So now we just start doing the stuff like we were doing on the last problems. HO, HA.
Except you got an A, a B, a C, a D, and an E.
Yeah, but it's all doing just the steps. That's all it is. All right, so this is A. This is part A that they're asking you to do. The HO, can we use their claim as the HO? No. So that's got to be the HA. So we put it in right here. That's the claim. Then that means our HO is going to be P is greater than or equal to 0.25. Step B, if you want me to, I'm probably not going to, on the rest of the problems, I'm probably not going to put the A and B, because all they're doing is leading you through step by step. All right, like I did with these. That's all it's doing, it's leading you through step by step. Step B, draw your little chart. It's horrible. Right tail.
See, that's where we should love it.
So we're over there. Is that right?
No, it's left. Oh my.
Ignore that. It's left tailed. I looked at the wrong one. So it's left tailed. We got to find this. The way we're going to find that is by using our alpha. Our alpha is 0.05. If it's left tailed, all you do is look on the chart. We know it's going to be on the negative side. So we try to figure out where 0.05 is. And some of these we use over and over again. So you should be able to, know that we're going to use it again and again and again. 0.05 is right in between. That's the one that's right in between, isn't it? Negative 1.64 and negative 1.65. So I'm going to put negative 1.645. That's our critical value. Then we find our Z. This is part C. Find our Z. We said that P hat was 0.185 minus 0.25. This one I can't do in my head. Over square root of 0.25. What's Q if P is 0.25? 0.75 divided by N, which is 200. Somebody do all that and just tell me the final answer.
Negative 0.06.
Yeah, just write down on your paper and just tell me the final answer. I'm tired of writing up here. Carson's about ready to fall asleep on me. Getting bored to death at this stuff.
That's kind of boring.
You understand it? Yeah. Just a lot of work. Anybody get it yet? it's gonna be negative.
Wow. -1.86.
Anybody agree with Carson? Get the same thing, or are you just gonna go with his massive brain
That's what I got.
and be a chicken crap? Gotta watch what I'm saying, I forgot about
Yeah, recorded.
Be scared to, cause think Carson's gonna whoop you or something if. Get something different?
Yeah. Here's something way different. But
Alright, so let's do it out step by step. I shouldn't have tried to get in a hurry, should I? What's the top?
I got -0.565.
That's what you got total?
Wait, that's for the top one.
I got -0.065.
-0.065 on the top?
Yeah.
Everybody agree with that?
Yeah.
What's the bottom? Sec,
0.031.
.031. Divide them.
-2.09.
Are we in agreement with that?
We are.
I got something different.
Is this yellow something?
Let's see here, .065 divided by, .065 divided by .031. Yeah, actually, if we round that up, 210, right?
Sure.
2.10. Where's that fall?
In the rejection.
In the rejection region. Now, the good thing, even though some of you, if you got that -1.86, where did it fall? It still fell in the rejection region. So sometimes you might get lucky and still get the correct answer. So what's that tell us?
That smokers or something.
What's it? It tells us to reject the null. In part E, that's when we look back at, if I can find my other paper here. We look back at this, all right? Look right here. Our claim was the HA, so we look at this column, and we rejected the null, so we're here, and we say there is enough evidence to support the claim. Well, what I'm going to start that with is with, watch how you write this, because this is how you're going to write every one of them, with a 5% level of significance, with a 5% level of significance, there is enough. So we write the, with the 5% level of significance, and we write this. There is enough evidence to support the claim. And what was the claim? What was the claim? What was the problem? What were they saying?
18.5.
Not 18.5, the other one, their claim.
Oh, less than 25% US, USA adults are smokers.
That less than 25% of adults are smokers. Don't make writing this out all that hard. The first part's going to be your level of significance. Then you're going to look at this chart to get the next line. And then the last of the next line is going to be how it relates to that certain claim or whatever it is that you're doing.
Sweet.
So what time was it? Was it grand?
850.
50?
there any of you want to see? Because I'm about tired of doing them. Wanted to at least get through that. Now you can turn that in. Find me one, and we'll do one more.
13.
13,
Just
just
you do 19.
13. I can do 19 maybe after this. 13, somebody read me 13 so we can write down the stuff.
Want me to read it again?
I don't care who reads it.
A research center plans at more than 75% females.
All right, so more than 75%, so that means P is greater than 0.75. What's Q then? Let's just find Q right now. 0.25. Keep going.
Ages 20 to 29 are taller than 62 inches.
So taller than 62 inches, all right.
Yeah, that makes,
Now, they threw a bunch of extra numbers in there that do we really care about?
in a random sample of 150,
150, that's in.
82% are taller than 62 inches.
82%, so that's our P hat, 0.82.
Alpha is 0.1.
0.1, so 10%.
There's enough evidence to point to center point.
Let's go quick here. HO, HA. Our HA this time is going to be that. P is greater than 0.75. Our HO then is going to be P is less than or equal to 0.75. We look back over here. Looks like it's right-tailed. Am I correct this time? It's right-tailed. We come over here, we draw our little graph. It's right-tailed, that's over here. So we're looking for that number over there. To find that, we're going to have to take our alpha and we subtract it from 1. So 1 minus 0.10, which is 0.90. We look up 0.90 on the chart. It's going to be on the positive side. Remember, it's probably not going to be on there, but something close. Looks like 0.8997 is the closest to 0.90. So that's 1.28. So that means our critical value here is 1.28. We do our Z. Our P hat is 0.82. Our P is 0.75. 0.75 times 0.25, that's our Q, divided by 150. On top, we end up with 0.07. On bottom, somebody figure all that out for me.
Tom's tired all the time.
Just think what's going to happen next year.
0.001.
Have to be an adult. Yeah, I'm a summer to recuperate now.
What is it?
0.00135.
Is that what everybody got on the bottom?
Yes, sir.
001?
Yeah.
Seems awful small.
I got that before I did square root of
Oh, so Jesse didn't take the square root.
No.
So what's the square root?
that. 0.03535.
0.036, we'll say. That seems better.
Yes, that's good.
What's 0.07 divided by 0.036?
1.94.
Check it. Does that fall in or outside the rejection region? So it falls in the rejection, so that means we reject the null. What are we going to write if we reject this null?
With a.
With a, that first part,
10% interval or something.
with a
With a 10%
level of significance.
level of significance. Now we look at this chart with a 10% level of significance. Our claim, I forgot to write which one was the claim, it was this one.
Yep.
So the claim was the alternative hypothesis, which is here, and we rejected the null, so we're looking right here at this box. There is enough evidence to what?
To
Support the claim. Enough evidence to support claim. What was the claim?
10% of people are taller than something.
Not 10%.
25 or 82. I don't know. 75.
75% of
Women are taller than 62 inches.
women are taller than 62 inches. The claim that
Would it be less than? The point was less than 75.
no, the claim was,
Oh, never mind.
I forgot to mark it there. So our alternative hypothesis was a claim this time. So claim that more than 75% of women are taller than 62 inches. Anybody know how tall 62 inches is? 5'2". So probably most women are taller than 5'2", right? 5'2" is pretty short.
That's very short.
All right, make sure your names are on those, and you can lay them right here. Sean and Jesse, you guys can go ahead and go. Might want to make sure you get the assignment off somebody. Grant, you really want to see me do 19? You say nah? Sure.
Yeah.
You're fine.
On this, write down this title when you get back. These are the notes for today. We're going to do Chi chart, or the Chi test. Make sure you get them off somebody. Yeah, I'll probably put them on Moodle hopefully today. Hopefully today. The video, Jesse, the video will probably be on Moodle.
Alright.
Hopefully today. You work somewhere, Carson?
At the north.
Carson checked me out last night.
Sweet. Carson checked me out last summer. That's the one time I've seen her. I'm a painter.
I'm all over the place now. There's not like a full truckload of like pet and grocery stuff in, so there's like 2 hours of it, like dog food.
I gotta find stick water in the house. I was like, I broke a helmet last year. It's $15.
You don't have a, you know, just unload it. Forklifts and
No,
stuff.
that's like ship it all
My
out.
dad
Cut it all over.
nice. Got it, Jimmy.
My wife used to work at Kmart. She'd throw fit every day. They had a truck come in because the idiots that drove their trucks didn't pay attention to how they were driving.
I got
Yeah.
cut off by a truck
So the
last
stuff
night.
would throw all over the back and
All over the
it'd
place.
just be scattered everywhere. And you'd have to go in there and pick it up all up by hand. You couldn't use the
Oh, that's a
forklift.
shame.
And of course, at Kmart, there wasn't nothing but, there was like one man, I think, that worked at all of Kmart and
Which Kmart was it?
the one in Eden.
Is that place completely empty inside now?
Yeah, they got it like, they tore out walls and stuff. If you go by it on the side, you can see all the way down through there where they tore everything out and stuff. I don't know what they're doing.
What are they gonna do with it? Nothing,
I know.
probably.
All right, hypothesis testing with variance and standard deviation. This is using the chi. Remember, this is chi. Chi. Use the chi test to test the variance and standard deviation. Basically the same setup that we've been doing this whole chapter. You're going to do that same process. It just changes a little bit because you use a different chart. You got to find the critical values a little bit different. But it's basically the same thing over and over again as we've been doing.
Why do they call it chi? It's a fancy X.
No, because it's not an X. X is a American alphabet letter. Chi is a Greek alphabet letter. Chi. That's a chi.
It's a capital X.
That's an X.
For
do this, to find the critical values, this is very important.
Nothing.
To find the critical values, specify the level of significance. That's the first thing you're going to do. Find your alpha. If you can't tell that that's an alpha, make sure you write it the correct way so that you can tell what it is. It's not a little a, it's an alpha. Next thing you do, determine the degrees of freedom. Remember, find the degrees of freedom. You just take, find your DF, you just take n minus 1. Then, there's 3 things here. The critical values for the chi distribution are found in the table, in table 6b. I probably wouldn't write all this right here, but this part right here, these next 3 things, the A, B, and the C, I would write those. If it's right-tailed, you just use the alpha. If it's left-tailed, use 1 minus alpha. If it's two-tailed, you do half of alpha and then 1 minus half of alpha. So it's sort of backwards to using the Z-chart. All right, and it's backwards because the Z-chart tells you the area on the left, the chi chart tells you the area on the right.
Why would we come back to the Chi chart also?
Do what?
What if we went back to the Chi chart also?
Same reason we went back to the T chart and the Z chart last couple of sessions. Because you're testing something different, Grant. Now we're testing variance and standard deviation. And Jacob, I was sort of wrong there, Dave, when I said percents. At your job, this is what you would be testing. You'd be testing this. Because you'd be testing your variance or your standard deviation, how much off it is on each one.
Yeah.
That's what it is. So when you told me the, whatever it was, 6/1000ths of an inch or whatever, that's your standard deviation.
You'd be surprised how much a single thousandth of an inch matters.
Yeah.
Oh, it does.
I wouldn't believe it until I had that job.
I know how much it matters just for some simple, I have a van, an old van that's got 210,000 miles on it. It hasn't ran for 2 months.
Yeah.
Because the starter is messed up in it.
Yeah.
And the reason the starter's messed up in it is because I keep getting starters from AutoZone that are rebuilt starters, and just being off, when they rebuild it, just being off that
Yeah.
little bit to where the Bendix doesn't kick out the correct amount, screws it all up.
Yeah, we had this 1-inch metal pin that had to go through a 1-inch hole, and when they machined the hole and the pin, and they machined the pin .9999, and then they machined the hole as 1001. So that 1,000 difference makes it slide easy. But then they had the base for the hole was powder coated white, and powder coat builds up pretty bad around edges.
Yeah.
So we just reamed that out, got all that paint out. But then when we tried to put the pin in, it wouldn't go. So they measured it with some calipers, and they figured out that it was zinc plated, and that zinc plating built up 1,000th, and you couldn't see it at all. But it was enough to not let that pin slide.
I wouldn't think you'd be able to just clean it off. I think you'd have to take it back out and machine it.
Yeah,
all
what we
again
did is we took, they have these things called expandable reamers.
Yeah.
And it starts as 1 inch, then you tighten a bolt and it swells and you can get it up. So we added 1/8,000, and then it was .002 and .001, and then it worked. So that's what I do for a living.
Is it fun?
It is fun. It's super cool.
It's pretty crazy how when you look at something like that, that's just a little bitty part
Uh-huh.
of a big machine.
Yeah, what that was is it was a pin on the ground. It was a pin on the ground that had a bearing in it, and they put the pin in a track, and then they push that cart around and pick up the parts they need to build heating and air for cars.
right-tailed test, you just use the alpha. Left-tailed test, 1 minus alpha to find that area, and then you look it up on the chart. Remember, each one of these is giving you an area. It's an area that you're looking up on the chi chart. So it's giving you an area, that's giving you an area. When you look up this area, all you really have to look up is one of them, and then
Yeah.
it'll be the positive and the negative of that number. So right-tailed, it's going to look like this. That's going to be your rejection region. Left-tailed, that's your rejection region. Two-tailed, you got 2 rejection regions, and that's your fail to reject in the middle there. All right, an example. So how about that chi chart so that we can use it here in a second? Find critical value for chi squared value, and I keep saying chi chart, it's actually the chi squared chart. For a left-tailed test, when n is 11 and alpha, that's an alpha, is 0.01. So first thing we want to do, we want to find our DF. Well, if n is 11, then our DF is 10, and we're just going to use that 10 and that 0.01, and this time we are left-tailed. So if we go back, I hate when I put pushing on these. If we go back, we're left-tailed, so we got to do 1 minus the alpha. So for left-tailed, we're going to do 1 minus that. So 1 minus 0.01, which is 0.99. If we have 0.99, we look that up on our chi chart.
I don't have one.
Degrees of freedom, we're at 10. 0.99, what's it tell us our critical value, our chi squared 0 is?
2.558.
2.558. So that's our critical value. Let's hope we did it right. Let's see what it says. Degrees of freedom 10. We're right there. 1 minus that, 0.99. We come up with 2.558 is our critical value from the chart. Make sense? Pretty easy. Next one, if we're two-tailed, our N is 9, so our DF is going to be 8. Two-tailed, we take 1/2 times that, 1/2 times 0.05, so that's going to be 0.025, and then we do 1 minus that, which is 975. 0.975. And we need those two numbers, but they're actually going to match up, so we only really have to look up one of them, I think. Let's see, we're 8. And we go over to 0.025. Looks like it's 15.507. Remember, these numbers are going to be bigger than the Z-scores and the T-scores because the way chi and chi squared is set up. What if we go to 0.957? Is that different? 975. Hey, they are different, so we do need both of them. So I lied to you. That's one of our numbers. Our other number, we got to look it up also. 0.975. It's not just the positive and the negative. 975 is 2.180. That's right, that's stupid. I don't know why I thought that. Because chi's are always positive. I don't know why I thought. So those are our two numbers. So our graph's going to look something like this. Remember, your chi graph doesn't look anything like that. Your chi graph actually looks like this, where it's got that longer tail on the right. This one out here is 15.507. This one back here is 2.180. These are rejection regions. Please make sure you don't mess up and do what I just did. Those are both positive, not one positive and one negative. We did that, got our DF. Figured out that, the two sides, one there, and our two values are 2.180. I think it's 17. I got something different, didn't I? I got 15. Did I look at it wrong? 0.025. Yeah, I did. 17.535. I looked at the one right next to it. So this should be 17 on that side. I just looked at the chart wrong. Alright. To test a variance or standard deviation, I wouldn't write any of this down. Statistical test for a population variance or standard deviation is your chi-square test. Can use it when the population is normal. There is one thing on here I think we're going to write down. The test statistic is your S squared. Remember that's your standard or your variance for the sample. This is the one thing I would write down, this formula right here. So use that formula is how we're going to find our standardized test statistic. This is the formula like we were just using for Z that you're going to use on every problem. Thought you got lost, so. Moving on. Might ask one of the young ladies there, they might like to see their notes or something if you get a few minutes. Unless they just don't like you then. So use that formula, that's your chi-squared, that's going to be what you're testing. You're going to see where that falls at in your graph. This is the part I would write down. Trying to do this on every one of these to just help you out. Number one, again, would I write all this down? Probably not. Probably just write this out here. Some of them won't have something out there though. So the first thing you do, find the null and the alternative hypothesis. Carson's getting bored because have we done that same thing every single section in this chapter? Yeah. Number two, identify the alpha. Find the alpha. That's real hard to do. Make sure you know where to find the alpha by reading the problem, right?
Who made this PowerPoint?
Some of it me, some of it somebody else. Why, you don't think I was smart enough to do something like this?
No, it was an A, and we yelled at you enough.
Nah, I made it last year and I just hadn't went through and changed them because. You're right, I probably made it 2 years ago. Number three, determine the degrees of freedom. So find your DF, which is just n minus 1. That's what you're going to do on every problem. Doing these steps. Number four, determine the critical values. You might want to write this down here. Somebody help me out. If it's, which one did we have first on the previous notes? Left-tailed or right-tailed? On the previous, on a couple slides ago. That when it said A, B, and C, which one was first?
Oh shoot.
Nobody knows?
Right tail.
Right-tailed? If it's right-tailed, what do you do?
A.
It's just the alpha, right? Right-tailed, it's just the alpha, and you look up the alpha on the chart. Alpha and DF. Left-tailed, what do you do? 1 minus alpha, right? You do 1 minus alpha, then you look that up on the chart. If it's two-tailed, if it's got two tails, then you do 1/2 times alpha, look it up on the chart, and 1 minus 1/2 times alpha, look it up on the chart. So those are to find your critical values. Right-tailed, you just use alpha straight out. Left-tailed, You do 1 minus alpha, look that up on the chart, two-tailed. You do 1/2 times alpha and 1 minus alpha, look those two numbers up on the chart. Next step, determine the rejection regions. That just means draw. So you might write out here, draw your chi. Remember chi, the graph looks more like that. It's sort of pushed to the right. Sorry. Number 6, use that formula. Chi squared equals n minus 1 in parentheses times s squared divided by sigma squared. Can everybody read that all right? There. Once we find that test statistic, once we find that chi-squared, then we're going to make our decision. Does it fall in the rejection region, or does it fall in the accept region, or the non-rejection region? That's the next step. Make a decision. So you either reject or fail to reject. And then what's the final thing? What do you do after you decide to reject or fail to reject? Interpret it. You interpret it. You write it out. You write, with a 5% level of significance, we can, or there is enough evidence to reject the claim that, whatever the rest of it says. Riley, you can handle all that? Easy stuff. A dairy processing company claims that the variance of the amount of fat and whole milk processed by the company is no more than 0.25. You suspect this is wrong and find that a random sample of 41 milk containers has a variance of 0.27. At a level significance of 5%, is there enough evidence to reject the company's claim? Assume that this is normally distributed. So all I'm going to do this problem. We'll see if we do it right. I haven't even done any of these yet, so hopefully I don't mess it all up. Let's see. Their claim is that their claim is that their variance is 0.25, so that's their claim. You do a sample of 41, and you find that your variance, your S, remember that's for a population, or for a sample, and this is for a population, is 0.27. And your alpha this time is 0.05. We're going to test all that, see if it works. First thing we're going to do, HO, HA. Your HO, this time, hold on, it didn't say, is no more than, so this shouldn't be equals, this should be no more than, so should be that. That's going to be that, that's our claim. Our HA then is greater than 0.25. What did the next step say to do? Find the critical value, or no, find alpha, right?
Yeah.
That's real hard. Alpha is 0.05. Now we find the critical values. We're going to draw our little chi graph. If we have this, or we left-tailed, right-tailed, or two-tailed, might be something that we want to write down. I think I just erased it then. Which one is it? Somebody help me out from, since I erased mine. right tailed. So we're here. Might be something you want to write down again to make sure you got it there somewhere. So we're looking for that value, we're right tailed. If we're right tailed, what do we say to do on the right tail? For right tail, all you gotta do is look this up, right? What's our DF?
40.
So on our chart, grab your chi-chart, chi-squared chart, go down to 40, and go over to 0.05. What's it tell us? 55.758. Is that right? Notice these numbers again, they're a lot bigger than the Z and the T's. So that's our rejection region there. We found our rejection region. Next thing we're going to do is find our chi-squared. That's what we're testing. The formula we got over there, n minus 1, so 41 minus 1 times s squared. Well, s squared, it's already squared. All we got to do is put it in there. 0.27 divided by sigma squared, which is 0.25. I write that formula correctly? There ain't no square roots in this one. Is that right?
That's right.
We do all this. Try to do some of it in your head. 40 minus 1 is, or 41 minus 1 is 40. So just take 40 times 0.27. It equals, divided by 0.25. I end up with 43.2. Then we make our decision off of that. 43.2 looks like it's going to fall somewhere about in there. So do we reject or fail to reject? Fail to reject. Fail to reject the null. Then once we know that, once we fail to reject it, again, you're going back to this chart every time. I gave you this chart last time. We look here, the claim was the null. So we're here and we fail to reject it. So what we say is, with a 5% level of significance,
Well, that's sketchy.
there
Look,
is, we failed to reject, so there is not enough evidence to reject the claim that the milk contains less than 0.25. What is it? The whole milk process brings the amount of fat. So less than 0.25 fat, or less than 25% fat. See if we did this right. We got that. That was our claim. Looks like we did that right. 0.05 was our alpha. The DF was 40. We drew our little thing, our rejection region, 55.758. That's right. Found our chi-squared, 43.2. Made our decision off that. We failed to reject. At a 5% level of significance, there is not enough evidence to reject the company's claim that the variance of the amount of fat in the whole milk is no more than 0.25. Their English is a whole lot better than mine. Your guys' will be better than mine too, right? When you write it on the test, right, Shania? Your English is going to be better. You probably laugh at my English all the time because you guys didn't know I was actually born in France, did you?
do you know I wasn't born in France? You weren't around.
France to Provo County is a pretty big move. I don't think anybody in their right mind would make.
All right, that's your assignment, page 410, 5 through 13, 15, 16, 21. I'll tell you what. Pick me 2 problems off of here.
20.
Thing. 20 and what?
15.
Get rid of those 2.
I was gonna say number like 8, see what you can say, but
I just wrote 8 and marked it out.
2 fewer problems, make it a little easier on you.
My graduation present, most of it. Except for those ones who aren't gonna make it.